Welcome to part 4 of the series on number theory and computations. And in this one, we'll be looking at number bases and place values. Okay, I think this is an interesting concept because when we think of numbers, everyday numbers, like for example, 5,946, 380, or even 41,752, these are all numbers in base 10 or based on powers of 10. Okay, so first, let's talk about number bases and place values. The position of a digit in a number is called its place value. For example, 5,946 has 4 digits, 5, 9, 4, and 6, each of which has a specified place value. And seeing as we are working with numbers in base 10, the different place values are the ones or the units position, tens, hundreds, and thousands. And these are all represented by powers of 10 as aforementioned. So 10 to the third power represents the thousand place, 10 to the second power is 100, 10 to the first power is 10, and 10 to the zero power is 1. And we place each of the 4 digits in their respective places. And so the thousands, hundreds, tens, and ones are what we call the place values, while the digits 5, 9, 4, and 6 are the faces. To represent the number 5,946 in a sort of base number system, we find the sum of each face multiplied by its place value. And we write this as 5 times 10 to the third power plus 9 times 10 to the second power plus 4 times 10 to the first power plus 6 times 10 to the zero power. And you'll see why we do this later. We can also expand this to get, or simplify this to get 5 times 1,000 plus 9 times 100 plus 4 times 10 plus 6 times 1, which is 5,000 plus 900 plus 40 plus 6, which is equal to 5,946, the exact number. And just to reiterate, these numbers are in base 10, and there's a special name for numbers in base 10. They're called denary numbers. So let's do another example. How about 380? Note, we can put a little small subscript 10 here to indicate that it's in base 10. However, as I mentioned before, most numbers that we use are already in base 10, so the specification isn't really needed. Okay, so we write our place values, the ones unit, the tens place, 10 to the first power, the hundreds place, 10 to the second power, and we put our digits in their designated areas. So now 380 in its expanded base number system form looks like 3 times 10 to the second power plus 8 times 10 to the first power plus 0 times 10 to the zero power. One more example. 41,752. Now our place values are 10 raised to the zero power or 1's place, 10 to the first power or 10's place, 10 to the zero power or 100's place, 10 to the third power, the thousand's place, and 10 to the fourth power, the 10,000's place. Then we align all of our digits or faces. And in its expanded form, this would be 4 times 10 to the fourth power, plus 1 times 10 to the third power, plus 7 times 10 to the second power, plus 5 times 10 to the first power, plus 2 times 10 to the zero power. And now this leads to a very important point. There are numbers in bases other than base 10. And the way we handle them are somewhat similar to the numbers in base 10. For example, the number 1,101 in base 2, unlike numbers in base 10, we have to specify that a number is in a base with this little subscript. So we put a subscript 2. And our place values, instead of base 10, it's now base 2. And this would be 2 to the zero power, 2 to the first power, 2 to the second power, 2 to the third power, and align all of our 4 digits. 1, 1, 0, 1. Now, 1101 base 2 in its expanded form is 1 times 2 to the third power plus 1 times 2 to the second power plus 0 times 2 to the first power plus 1 times 2 to the 0 power, which is 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. And this leaves us with the sum of 8, 4, 0, and 1, which is 13 in base 10. And now we're seeing the importance of this expanded base form, as it allows us to convert a number from any base to a regular denary number. And an aside is that while numbers in base 10 are called denary numbers, numbers in base 2 are called binary numbers. And these are the only two bases with special names as far as we're concerned. And for every other base, we just say base 4 or base 3 or base 5, etc. So let's do a second example. 2102 in base 4. First thing is to write our bases in powers of 4. So we have 4 to the 0 power, 4 to the first power, 4 to the second power, and 4 to the third power, which are our place values. And we align our digits. Now, in expanded form, we have 2 times 4 to the third power plus 1 times 4 to the second power plus 2 times 4 to the 0 power. When we expand everything, we get 2 times 64 plus 1 times 16 plus 0 times 4 plus 2 times 1. And the answer is a sum of 128, 16, 0, and 2, which is 146. The last thing we look at is values. So the value of a digit is equal to the place value of a number multiplied by the face or digit of that number. So if you scroll back up to the first number we looked at, 5,946, then the value of the digit 9, which I underline in red, is its place value, which is 10 raised to the second power, 100, multiplied by its face, 9. And so the value of the digit is 900. Again, let's look at 6, which is in blue. The value of 6 in the number is its place value, 10 raised to the 0 power, 1, multiplied by its face, 6. And so 1 multiplied by 6 is 6. 6 is the value of the 6 in this number. Now let's look at the value of 3 in 380. This would be the place value, 10 raised to the second power, 100, multiplied by its face, 3, which is 300. The value of 5 in 41,752 is its place value, 10 raised to the first power, 10, multiplied by 5, which equals 50. The value of the underlined 1 in 1,101 base 2 is the place value of the 1, 2 to the third power, which is 8, multiplied by its face, 1. So 8 multiplied by 1 is 8. So the value of the underlined 1 is 8. Let's look at one more. What is the value of the 0 in 2,102 base 4? The place value of 0 is 4 raised to the first power, 4, multiplied by its face, 0. So 4 multiplied by 0, which equals 0, is the value of 0. And this is the end of this video. Subscribe to this channel so that you'll be notified about part 5, where we'll handle conversions between the different bases. And like this video so that our content might come across to others who might also be interested in these types of videos.